Today, I will demonstrate a VFD-based speed probe setup which is used for testing and verifying speed probes and VFDs in instrumentation systems. This setup is useful for calibration, testing and training purposes in industrial plants.
This training module consists of 3-phase power supply which provides electrical power to the VFD. The VFD controls the speed of the motor by varying the frequency. By adjusting the VFD frequency, we can simulate different rotating speeds. The acrylic sheet provides insulation and protects against the 3-phase power supply, preventing accidental touch while allowing the visibility. The tachometer unit receives signals from the speed probe and converts them into RPM readings. The coupling protection ensures operator safety by preventing accidental contact with rotating parts. The speed probe detects the rotation of the shaft or coupling and sends the pulses to the tachometer. The motor acts as the rotating element of the setup, similar to the rotating machinery in industrial plants.
Now I will briefly explain the working principle of this setup. When the motor starts, the shaft begins to rotate, and the coupling mounted on the shaft rotates along with it. A notch is provided on the coupling which acts as the target for the speed probe. The notch has a diameter of 8 mm and a depth of 6 mm, as verified from the AI Tech Instruments manual for this type of speed probe. The speed probe used in this setup is a passive magnetic pickup sensor. As the notch passes in front of the probe, the changing magnetic field induces electrical pulses in the sensor. The probe is installed at an approximate gap of 1 mm from the coupling, which ensures proper signal generation and accurate detection. These pulses are then transmitted to Tactrol 30 tachometer. The tachometer processes these pulses and calculates the rotational speed of the shaft. Finally, the speed is displayed in RPM on the tachometer display.
Before running the motor, we first configure the motor parameters in the VFD according to the motor nameplate. First, we go to the main menu, then we select Load and Motor Settings. After that, we enter the motor data section. Here, we set the motor power, then the motor rated voltages, followed by the rated frequency, which is 50 Hz. Next, we enter the motor rated current and finally the motor rated speed in RPM. After entering all the parameters, the VFD is set and ready to control the motor for the speed probe testing setup. With these precautions in mind, we can safely use this setup for demonstration and testing. This training module provides a simple and practical way to test and verify speed probes using a VFD controlled motor. Thank you for watching this and stay tuned for more practical instrumentation demonstrations.